In this video, we're going to continue the preliminary chapter, Chapter P. This is Section 3, and the topic is polynomials and special products. So if you remember the FOIL method and some of those tricks, we're going to be seeing those a little bit later. But first, it's our official book definition of a polynomial in the variable x. So it says, let a sub 0, a sub 1, a sub 2, ... all the way out to a sub n, some number n way out there, be real numbers, and let n be a non-negative integer. A polynomial in x is an expression in this form. We have some coefficient, some number, that's our a sub n, and then we have our variable x raised to some power. And then we have plus or minus. A to the, now the sub or the base of this is n minus 1. It's another coefficient, and our variable x is now not to the nth power, it is 1 power lower, n minus 1. And we would continue on in that with the exponent above the x getting smaller and smaller as we go along the polynomial. Eventually we'll have some coefficient times x to the first power, and then we'll have just a constant sitting at the end, just some number a sub 0. And it says here a sub n does not equal 0. So our leading coefficient does not equal 0. The polynomial has a degree of n, and that's just the highest exponent. Here the highest exponent is n, so that's the degree of the entire polynomial also. A sub n, that is our leading coefficient. It's just the number in front of that first x to some power. The very last thing in the string of the polynomial is a constant term, if that polynomial does have a constant at the end. So when you look at this, all these a sub number, a sub n, x to some n power, that looks kind of confusing. The big idea is you're going to have some number, and let's just say your first coefficient or your first variable is x to the 7th. And then you might have plus some number x to the 6th. And then minus some number x to the 4th. And then plus some number x to the first power, and then plus 2. And again, I left those blanks. Those are just coefficients. You can plug in a 2, a 3, a 7, a 9. It doesn't matter. The big idea, it's written in descending order. We have our x to the highest power first, x to the next power lower, and lower, all the way down to the constant. That is a polynomial in the variable x. And what we're going to do with this is pretty basic stuff. You should remember this. Even this goes back all the way to Algebra 1. What can you do with polynomials? What different operations? Well, we can add or subtract them. We can find the sum and difference of two polynomials. Taking the sum is the easiest. If you have here a polynomial in a set of parentheses plus another polynomial in a set of parentheses, the parentheses don't mean anything. So we can just ignore the parentheses and collect like terms. 5x to the third plus another x to the third is 6x to the third. Minus 7x squared plus 2x squared leaves us a minus 5x squared. Here's a minus x, and there's no corresponding x term over here, so we just keep this as a minus x. And then we have a minus 3 and a plus 8, and negative 3 plus 8 is 5. So there is the sum of those two separate polynomials. Again, when it's plus, it's easy. Ignore the parentheses, collect like terms. Letter B is where we find the difference, and that we can't be so quick with. Because here the parentheses do matter. It is one polynomial minus another polynomial. So we have to use the distributive property first. Here you can almost imagine in between the negative and the parentheses there is a 1 there. That's a negative 1. We are going to distribute that negative to each of the other terms. So the first thing I do is copy the first polynomial as is, 7x to the 4th minus x squared minus 4x plus 2. Now we distribute the negative, which in effect is just going to flip every sign in the second polynomial. This was a plus 3x to the 4th in the parentheses. We distribute the negative, and now it's a minus 3x to the 4th. Our next term was a minus 4x squared. Well, that minus is now a plus. Negative times negative is positive 4x squared. And our last term was a plus 3x. That negative is distributed and makes that into a minus 3x. And now that we distributed the negative, we can drop the parentheses, and now it's back to sort of like being the sum in the first part example here, part A. Now we're just going to collect like terms. So here are our x to the 4th terms. 7 minus 3 is 4. x to the fourth. There are no x to the third powers, so we move on to x squared. Minus 1x squared plus 4x squared is plus 3x squared. Make that look a little better. And we have a minus 4x and a minus 3x, so of course we have a minus 7x when we combine them. And then here we just have our one constant from our first polynomial. We tack on our plus 2. And the moral of the story is, be careful when you are subtracting polynomials. You have to distribute that negative, then you simply collect the like terms. This should ring a bell, the FOIL method. Finding a product by the FOIL method. Use the FOIL method to find the product of these two binomials. So I'm going to write them here in parentheses. 2x minus 4 times x plus 5. And of course, you know FOIL. First is 2x squared. Our outers are going to be a plus 10x. The inners minus 4x. And then we have minus 4 times 5. Our last terms will be a minus 20. Usually when you FOIL these out, the inner terms are going to combine. So the 2x squared stays. 10x minus 4x is 6x. And then we have our constant at the end, minus 20. So there's our product when we FOIL them out. There's a different way to do these, and this is useful if you have more than a binomial times a binomial. Here we have a trinomial times a trinomial. If we try to do it sort of by the same FOIL method, you know, keeping everything on the same horizontal line, that can get a little confusing with a 3 times a 3. So we can also do what they call a vertical arrangement. You know, maybe you learn to multiply some numbers like this, like 22 times 35. We'd write them, you know, one over top of the other. And then our 2 times 5 is, 2 times 5 is 10, so we have a 0, carry the 1. 2 times 5 is another 10, add the 1, we get 11. 3 times 2 is 6. 3 times this 2 is also 6. And then we sum them up underneath and add the columns. So 22 times 35 is 770. We're going to do something similar with a trinomial. So we're going to multiply these together. I guess it doesn't matter which one we put on top or bottom, but I'm going to have an x squared minus 2x plus 2. And I'm going to multiply that by x squared plus 2x minus 2. Or that's another plus 2. So I copied those down, and I guess we don't even really need those parentheses. Those are kind of pointless. So let's multiply. I'm going to start here on the right and work my way left. I'm going to multiply the 2 by everything above it. So 2 times 2 is 4. 2 times 2x is 4x. We'll keep this plus sign. We'll also keep this minus sign. 2 times x squared is 2x squared. And now I'm going to switch over to a different color. Now we're working on the middle term, 2x. 2x times 2 is 4x, and that's a plus 4x. 2x times the 2x above it with the minus sign, that's going to be a minus 4x squared. Minus 4x squared, and that will go in the column with the other x squared terms. And then here we have 2x times x squared, that's 2x to the third. 2x to the third. We're going to put that over there. And now that I'm looking at this, I might need a little more room on the left. So I'm going to slide this over. And I'll change colors again. I guess I'll go to black here. So we did the 2 times everything above it and the 2x times everything above it. Now we'll do the x squared. X squared times 2 is 2x squared. X squared times this minus 2x in the middle is minus 2x to the third. And then x squared times the x squared above it is x to the fourth. And now we can add all the columns. So here we have a 4, that comes down. Plus 4. Minus 4x and plus 4x, that sums up to 0. They cancel out. Let's see here. If we add the positive ones, 2x squared plus 2x squared is 4x squared. And then we have a minus 4x squared in there. So all of this also sums to 0. 2x to the third minus 2x to the third, that also sums to 0. Look at that. So we have our leading term here is x to the fourth, and we come all the way over here and have our plus 4. X to the fourth plus 4 is the product of these two trinomials, multiplying them together. So example 4 is done. Move on here. You might remember these from Algebra 2. We have our special products. You know, if we have a sum and a difference of the exact same terms. You know, in our first term it is u plus v. In the second term it is u minus v. The only difference is the plus and the minus. You have one of each. If you FOIL that out, you'll have the middle terms cancel, and what you're left with is the first term squared, u squared, minus the second term squared, v squared. So if I gave you this problem, what is x plus 4 times x minus 4? You could say, well, that's a sum and a difference. So I'm going to take the first term and square it, x squared, and I'm going to have a minus sign. It's always a minus sign. And I'll take my second term and square it, 4 squared. So that turns into x squared minus 16. If you want to square a binomial, if you have u plus v quantity squared or u minus v quantity squared, you just follow this similar pattern. If it's a u plus v squared, you have the first term squared, u squared. The second term squared is v, and the middle term, here the middle term doesn't cancel, but it is 2 times u times v, whatever they are. So if we come over here and look at an example, x plus 3 quantity squared, well, we know the first term is the first term squared, x squared. The last term is going to be the second term squared, so that 3 becomes 3 squared. And the middle term, I'll underline it in red, is 2 times x times 3. 2 times the first term times the second term. And 2 times 3 is 6, and then we have our x, 6x in there. 3 squared is 9. So we have x squared plus 6x plus 9. You know, that'll work all the time if you memorize the shortcut. If you want to just FOIL out the binomial, that will work also. You could just write out x plus 3 times x plus 3 and then FOIL it and collect your like terms, and you'll wind up with the exact same final answer. The only difference is if it's a subtraction, if it's a difference of these two terms and we're squaring that. The only difference is this sign is now a negative. The first term squared, our last term is squared also, and it's always plus. The middle term is now minus 2 times u times v. So here, let me clean this up a little bit. If you have 3x minus 2, that quantity squared, you take the first term and square it. 3x quantity squared is 9x squared. Take the last term, that here is just a 2, and square that. 2 squared is 4. The middle term is 2 times the first term times the second term. And this sign will always be a minus. 2 times 2 is 4, times 3 is 12, and then we still have that x, minus 12x. We also have a similar formula, this is probably new, the cube of a binomial. Now it's to the third power. So here it's a little bit different. We have the first term to the third power. The last term v will be at the very end to the third power. Now what goes on in the middle is we always have a 3. That's just part of the formula. We always have a coefficient of 3. And look what happens with the variables. First, you know, we had u to the third. Now it's u to the second, 1 power lower. And we have v to the first power. In the next term, u squared drops down to now u to the first. Here was v to the first. That now is bumped up to v squared. So those are our two terms in the middle. Again, a number with or an example with some numbers in it here is x plus 2 to the third power. Take the x, cube it. That's our first term. The last term will be the 2 to the third power. The two terms in the middle, now there's two middle terms. We have 3 is in both of them. And then we have x to the first power times the second term, or I mean x to the second power times that second term 2. And the second term there in the middle will be 3x to the first power. Now that's dropped down 1 power. And we're taking this term and squaring it. We're taking that 2 and squaring it. And then when we multiply the 2 times 3 is 6, x squared. Here we have 2 squared is 4 times 3. That becomes a 12x. If it is the difference of a binomial, the pattern is exactly the same. The only difference now is a couple of signs. In the sum of two terms, this was a plus sign. In the difference of two terms in a binomial, it to the third power, and now it is minus. This term is always plus. Here we change the final term from a plus to a minus. So you just have to sort of memorize those patterns where the 3's are and where the pluses and minuses are. And let's try some of these out. Come on, there we go. So find the product of these two terms, 5x plus 9 and 5x minus 9. You could write them together, 5x plus 9 times 5x minus 9, and say I can FOIL those out. And you could do first, outers, inners, last. And then you could collect your like terms, and you'd have the product, the correct answer. But if you recognize the pattern, that this is a special case, that this is a sum and a difference, what I like to do is come under the one here with the minus in it, and just square the first term. This term quantity squared would be, well, 5 squared is 25, x to the second power. The minus comes down with it, and then we square the second term. 9 squared is 81. 25x squared minus 81, and we're done. That is our sum and difference, our special product. The next one, square of a binomial, 6x minus 5 squared. Again, you could write out 6x minus 5 times 6x minus 5, and you could FOIL that out and get the right answer. Or we could do it the shortcut way, 6x minus 5 squared. I'm going to come underneath it, and I'm going to square the first term. 6 squared is 36, x squared is x squared. Take the final term, square that. 5 squared is 25. Because this sign is a minus, we're going to have a minus sign first here, and then plus. Think about it this way. When we square negative 5 times negative 5 is positive 25. But what is this middle term? Remember, the middle term is 2 times the first term, 6x, times the second term, 5. And when we multiply that out, 6 times 5 is 30, times 2 is 60. 60x minus 60x will be our middle term. Time for some practice problems here. Pause the video, try these problems, and then start the video back up and check your answers. See how you did. Okay, let's see how you did here. Get some of this out of the way for now. The first one, we're summing two terms, and they do throw a little twist on it. In the parentheses are our binomials, and we're summing them up. So first thing we have to do is distribute anything outside those parentheses. And on this one, we do have a negative in front of our first binomial. So let's distribute this negative. That'll be a minus t to the third. And then a minus times a minus 1 is a plus 1. And since we're adding here, it's plus. We sort of distribute that plus, and that means nothing changes. That's still going to be a plus 6x to the third. And why did I say x? That's a t. T to the third. And then a minus 5t. So now let's collect up and combine what we can. Our third power variables, 6t to the third minus 1t to the third is 5t to the third. We don't have any squared terms, so we'll move on to first power. Minus 5t to the first is our next term. And then we're left with our constant, plus 1. And there we go. That's the sum of those two binomials. Number 47 looks like we just have to do a distribution. Out front, we have a minus 5z. We're going to distribute that to the two terms in the parentheses. So minus 5 times 3 is minus 15. Z times z is z squared. Minus 5z times minus 1. The negative times the negative is positive. 5 times 1 is 5. Z to the first power. Or just leave it as z. Okay, the next two, 64 and 67, are multiplying. Multiply the special product. And let's see here. This is not a sum or a difference, so this one we're just going to have to FOIL. first times first is x squared. Outers, plus 10x. Inners, minus 5x. Last terms, minus 5 times plus 10 is minus 50. And usually on these we can combine those middle terms. So we have x squared, 10x minus 5x is plus 5x, and then we have our minus 50 at the end. Okay, one more. This wasn't too bad. Here we do have a special product, a special case. We could FOIL it like we did in 67, but I notice it's a sum and a difference of the same two terms. So I focus in on the one with the minus sign, and I just say, well, I'm going to square that first term, x squared. I'm going to bring the minus sign down, and I'm going to square the second term. 10 squared is 100. X squared minus 100. So there's the practice problems. Here are a few homeworks to try on your own. Enjoy.